Hello and very good morning, my dear students. I hope you're enjoying integration and you're doing the sums properly, seriously, thoroughly. Okay, so let's get started today. Forms which we have seen in the previous video, I have written here integration of dx upon ax square plus bx plus c, integration of px plus q upon ax square plus bx plus c, and integration of dx upon under root ax square plus bx plus c. So let me again recall it, that what we have seen in the previous video. How to integrate this thing, I have explained you one method that is called completing the square method. If you are remembering it, say for example, if you have x square plus 4x plus 1, so what we do, we see the coefficient of x, that is 4, dividing by 2, we are getting 2, and we are squaring it. So square of 2 is 4, so we add plus 4 and we subtract plus 4, and then this x square, 4x, and this 4, we write it closely, and 1 minus 4 will get 3 as an answer. Here we'll get x plus 2 the whole square, and this as root 3 the whole square. And we use the identity here. This can be written in place of here, and we use the identity, whatever which is applicable in it. Okay, then I've explained you, for this question I've explained you, we put the numerator, that is px plus q, as d dx of ax square a into d dx of ax square plus bx plus c plus b, and then we differentiate it and we multiply a inside, and then we compare the a coefficient. Here p will be equal to 2a capital A small a, and q will be equal to ab plus b, and then we get the value of a, we put here in this equation a and b, and similarly we place this in place of this expression, and then we divide, we separate it in two. The one will be substituted and the another will be solved in such a way. And in this one, you have to do the same thing of this form. The only thing is you have to put this root in each and every step. All the things are very same with respect to this the criteria of this solution. Okay, so this three forms you have to clear it very thoroughly. Now we are going to head to this topic where it says px plus q upon under root ax square plus bx plus c dx. Alright, so let's see this form. Okay, so let us see one question of it. Integration of 5x plus 3 upon under root x square plus 4x plus 10 dx. So 5x plus 3 here, I told you we put numerator is equal to a times of d dx of this thing. Don't take this under root, you take only the expression which is inside the under root, plus of b. Then differentiate this equation, that will give you 2x plus 4 plus b. Give this equation as star so that you won't confuse between these two steps where to put the values of a and b. So as of you differentiate, give that as a star equation. So 5x plus 3, multiply a inside 2ax plus 4a plus b. On equating the coefficients as the x term, so 2a equal to 5 and 4a plus b equal to 3. So from here a equal to 5 by 2, put the value of a here, you will get b equal to minus of 7. So put the value of a as 5 by 2 and b as minus 7, and in place of 5x plus 3, that means this one, we can put 5 by 2, 5x plus 3 minus of 7 whole divide by under root of x square plus 4x plus 10 dx. Now separate this term with this term, this term, and with this term. So 5 upon 2, 5x plus 3 upon this thing, okay, minus of integration 7 dx upon under root x square plus 4x plus 10. Okay, pardon, see here 5x plus 3 will not come, here 2x plus 4 will come, sorry, okay, so 2x plus 4. Okay, now what to do? You know what to do after this thing. We have to integrate this and this. You just say that let this be the I1. You integrate it separately. It would be very hodgepodge to do in the same thing. Okay, so what you do, consider this as I1 and this as I2 and integrate separately. Why we are doing so? Because if you substitute this x square plus 4x plus 10 equal to t, and which will give you 2x plus 4 dx is equal to dt. So if you combinedly solve, you need to substitute here and here both, correct? Because we don't need to substitute in this for solving this, we don't need any substitution method, but we need for this one. So what we do, we separately integrate it and then at last we'll write it combinedly. So here you do by substitution method, and here already this is of form under root of ax square plus bx plus c. Using the completing the square method, you can solve that question. Okay, so like this you have to do all the 4 forms, I guess, which are very easy for you to solve. So I expect and I hope that apart from your course book, you'll refer some other book also for solving it. Okay, so that is how we end this form, and please do 8.8 exercise and the example. Okay, the same patent word or patent dialogue which I tell you to do the examples and then the exercise. Okay, so best of luck for that. I felt that I should do some of the questions of the exercise. So let us give this video to this exercise, and in the next video we'll start with some new questions. That is, the new integration, the new form. Okay, so here is one question in front of you. That is integration of dx upon under root 5 minus 4x minus 2x square. Okay, so the same completing the square method we will be going to use in the denominator, but this is not in the proper form which the completing the square process requires. As I told you, some of the condition of the process, you have to follow those process. That means x square should be alone, totally alone. There won't be any minus sign or there won't be any coefficient along with it. So what I am doing, this is minus of 2x square. I'm taking minus common. So if I am taking minus common from this, so it will be plus of 2x square, minus common, so it will be plus of 4x, and this is plus of 5, so it will become minus of 5, and I have taken minus common. Now I don't want this 2 also, so I'm taking 2 common from this. So taken 2 common, so x square plus of 2x and minus of 5 upon 2. Now take this 2 out from the root, so 1 upon under root 2 and minus 1 is left here. Here, what is the coefficient of x? 2. Divided by 2, you will get 1. Square it, so you will get 1 square, that is 1 only. And you need to add this coefficient, that is plus 1 and minus 1 in this expression. So plus 1 and minus 1, and this minus 5 upon 2 which is going on. Okay, this completes the square of x minus 1 the whole square. X plus 1 the whole square. Okay, and this minus 1 minus 5 by 2 will give you minus of 7 upon 2. Now whatever you have taken minus common, no, just introduce this in the bracket, so it will be minus and this will be of plus, and I have written here like this. And if I want to fit this particular thing in my identity, this should be in the square, so root 7 upon 2 the whole square. Okay, because this is not a perfect square, so that is what we are writing in this form, just to represent this in square, and minus of x plus 1 the whole square. Isn't this looking like integration of dx upon under root a square minus x square, which is nothing but sine inverse x upon a plus c. So use the identity here, 1 upon under root 2 sine inverse. What is x? X plus 1. What is a? Root 7 by 2 plus c. That is the final answer. Okay. Like if you come to this question, it is the last question of exercise 8.8. It says integration of x square upon under root x to the power 6 minus 2x cube minus 3 dx. Now what to do in this question, you would be thinking. So as I told you that this thing should be replaced with dt. So to replace this thing that means you want x square. So how you will get x square? On differentiating the x cube, you will get x square, no? And in the denominator, you have something like that. So what we do, we are putting x cube is equal to t, and on differentiating both the sides, we are getting 2x square dx is equal to dt. So x square dx will be dt upon 2. Now replace this x square dx by dt upon 2. So that upon 2 I have taken out, and x to the power 6, it can be written as x cube the whole square. So that is what t square minus 2t plus 3. Now I guess this equation has been totally transformed in t, and this is very easy to solve using completing the square method in this expression. So the coefficient of t here is 2, divided by 2, you'll get 1, square it, you will get 1. You need to add that 1 and subtract that 1 here. So plus 1 and minus 1. T square minus 2t plus 1 will give you t minus 1 the whole square. Minus 3 minus 1 will give you minus 4, which is 2 the whole square. So what is the differentiation of dx upon under root x square minus a square? So this integration will be what? It would be log x plus under root x square minus x a square plus of c. Use this identity, you will get the answer. So here we have completed this exercise. In the next video, we'll see the further topic. Okay, till that, do the practice. Okay, thank you so much. Have a nice day. Bye bye.